Recording?
Yes.
Okay. All right, so the first demo is crunch time. And so in your foldable, under properties of air, I want you to write crunch time, and then you'll also write go with the flow, and you'll be summarizing the results of what happens here. So to set up crunch time, what I've done is I have water that I heated up in the microwave. Okay, and I'm gonna pour some hot water in both of these containers. Okay, I'm gonna cap them with my hand, I'm just gonna shake them around. So in doing this, I am transferring heat from the hot water to the air molecules that are in each of these containers, okay? Emily, would you be able to help me? Okay, would you come up and grab that cap? So what I'm gonna do is I'm gonna dump the water out of these, and right when I dump the water out, then Emily's gonna help me cap one of them, all right? So I'm gonna dump them. Okay, I'm gonna put the cap on that one.
I cannot have things.
Okay, so I'm gonna let these sit, and they're just gonna sit right here, thank you, Emily. And we're going to make some observations in a couple minutes with those two. Okay, but I'm gonna transition to the second demo next. So again, the second demo is called Go with the Flow. And basically what I have are 2 empty pop cans and a straw. Right, so watching what happens with the pop cans. So one of the things, to kind of back up, okay, I want these pop cans, well, no, let me rephrase that. Okay, I'm gonna blow down the center of these pop cans. What do you think is gonna happen to the 2 pop cans?
Move in separate directions.
Okay, they're gonna blow apart. Anyone think differently, or we agree that they'll blow apart? Speak now or forever hold your peace. Michael?
Well, I agree with that, but I also think it could like contract, depends.
So they would roll together?
Yeah, depends.
Depends on what.
Like,
How hard you blow?
yeah,
So if I, blow softly, what?
they'll probably go together, and if you blow hard, they'll probably pull apart.
Yeah.
Okay. All right, well, let's just, I'll have to think about, I don't know, does anyone else want to say anything? Agree with that, disagree with that? Not sure? I don't know, so if you can't see these two, if you want to kind of stand up or move to where, then actually I might grab a longer so I can. All right, here we go. Okay, so what happened to those?
They came together.
They came together, okay, now I don't know if I can, but I would, here, we thought that
They would go apart.
this one's being, there you go. So you thought, or said, one of the things was if I blow really hard, then they'll move apart, but I'm still blowing pretty hard, right? So if I blow harder, I think they maybe roll together faster. Versus, I'll try to blow it more softly. So do they still come together?
Yes.
Yeah, the speed maybe varies a little bit. Okay, so why do you think that these pop cans come together instead of blowing apart? Any thoughts on that? What, Travis? Is it still recording now?
Yes.
Okay.
Maybe it's like the air circulation underneath and it's like bringing them together because it might go under and then around and over together.
Okay, so when I blow the straw, what am I doing to the air in the space between the cans? Is that air still? Is it staying there or is it moving?
Moving.
It's moving, so I am think about the air molecules in between the can here. When I blow between the can, I am pushing those air molecules out of the way, and therefore it's like I'm creating some empty space in here, or at least some space with fewer air molecules. So then, as Emily is saying, air that's around all the other parts of the can then rush in, so underneath, on top, okay, they rush in and they create some pressure pushing those cans together. Okay, so essentially what I've created is in between the cans a low pressure area, again where there's fewer air molecules, and because this is lower pressure, all the other air around it is higher pressure, and that higher pressure air, those molecules want to expand and fill in this space, but on their way to expanding and trying to fill it in, they push the cans together. Does that make sense? So when we think about high and low pressure air is typically going to be air that's contracting, coming closer together. High pressure air is usually expanding, pushing outward, okay? And so that's where you have that. Okay, let's come back to my pop bottles now because they've done what they're going to do. So again, this is crunch time. And so what do you notice about these two bottles?
One of them is like coming in and one isn't.
Okay, so this one has shrunken and it's kind of shrunken into this square form, whereas this one looks like a regular pop bottle. Okay. So why is there that difference between the two? What happened? Karen?
Well, you put the lid on one of them and like the air molecules were trapped, so and they were hot, so they're like moving around pretty quickly,
Mm-hmm.
and they like cooled. No, they wouldn't have cooled down.
Mm-hmm.
They would have. Kidding. Well, yeah, and then it like shrunk because they had nowhere else to go, so they came inward.
Yeah. So as the air molecules in here, you have to think back to chemistry, right? When molecules are hot, they're moving fast, they have a lot of energy, they're bumping into each other and creating lots of space between each other. And when they cool down, they slow down, they have less energy, they come closer together. So as these air molecules were moving around inside this pop bottle, they were hitting the sides of the pop bottle and they're actually transferring some of their energy to the plastic, and therefore they were losing energy. Okay, and when they lose energy, they got colder, they slowed down, and they came together. So that created a low pressure area inside my bottle. The air around the pop bottle becomes high pressure, and so it is pushing in on this low pressure area. Whereas in this bottle, okay, what were the air molecules able to do in this bottle? Leave, or well, they didn't.
Air.
As these air molecules, well, some of the hot ones probably escaped out the lid, but then as these started to cool and contract, it allowed airflow to come in too. So there was this in and out flow to be able to equalize pressure. Michael?
Why did the steam go into that bottle?
The condensation, because there are the air molecules in here, as they cooled, were probably able to draw in some more water vapor from the air around. Whereas if I open this one, I don't know if condensation would form, it might have cooled down too much. But a lot of times you get condensation when you have really warm, moist air and then it condenses on a colder surface. So this might be because it was able to pull in colder air molecules and cool down faster. Alright, you can pause my video there. Thanks, Tyler.